Greetings. Welcome to our fourth episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign.
Hello, everyone. My name is Jen Miller, and I'm the coordinator of the Fabricated Geomembrane Institute, or the FGI.
Today's episode is titled Geomembranes 101.
Okay, so I think we should just go ahead and get started. So Geomembranes 101. Tim, what is a geomembrane?
The formal definition of a geomembrane by the International Geosynthetics Society is a planar, impermeable polymeric sheet used in civil engineering applications.
Okay. What types of geomembranes are there?
There are many types of geomembranes, and what differs between these geomembranes is the main polymer used to create the planar piece of plastic. For example, some of the polymers are linear low density polyethylene, LLDPE, polyvinyl chloride, PVC, flexible polypropylene, FPP, chlorosulfonated polyethylene, CSPE, EPDM, ethylene propylene diene, EVOH, ethylene vinyl alcohol, high-density polyethylene, HDPE, and there are other geomembranes comprised of polyurethane and bituminous material.
Okay. What are typical thicknesses and colors of geomembranes?
Geomembranes range from 1 to 2.5 millimeters thick or 40 mil to 100 mil thick, and they can come in smooth or textured finishes. And the colors range from black to white, green, blue, brown, depending on the application. Any pigment color can be added, so you can specify the color. The typical colors, though, for geomembranes are black, gray for the bottom liner system, which we'll talk about in just a minute, and green or brown if it's for a cover system.
Okay. So what would you say is the primary function of a geomembrane?
The primary function of a geomembrane is to limit the transport of contaminants from a facility or an impoundment to allowable levels.
Okay. And can you go through a few of the typical applications of geomembranes?
Yeah. Probably one of the largest uses of geomembranes is waste containment facilities. In this application, geomembranes are used in the bottom liner system. So this is underneath the waste that's being contained. And the purpose of the bottom liner system is to limit contaminant leaving this facility either by advection or diffusion. Another application in a waste containment facility is the interim and final cover systems. So an interim cover system could be a geomembrane placed over the waste overnight or for a week or a short period while the activities are on hold, or it can be a final cover system after the facility is completely filled with waste. Another application is using geomembranes and other geosynthetics for coal combustion residual disposal. Another application is in mining projects. These can be used for ponds associated with the mining operation, as well as leach pads associated with the mining operations. And for a leach pad, the geomembrane could be on the bottom, so it would act as a bottom liner system, and also a cover system over top of the leach pad. Another application is floating cover systems, and these systems utilize a geomembrane to isolate the liquid in the pond from people and the environment. And the liquids in these ponds could be potable water, de-icing fluid at an airport, leachate from a municipal waste landfill, or from a oil and gas project. Finally, one of the biggest applications is for potable water and canals to transport the potable water.
Okay, those are many great uses of geomembranes. So what are the key factors to obtaining a good geomembrane performance?
The first key factor is to minimize the amount of defects or holes that are caused or created in the geomembrane during the installation process. And the way to minimize the holes and defects is to have a good construction quality assurance and construction quality control procedure during placement of the geomembranes in the field. After the geomembrane is placed, then leak location surveys can be performed, and these are surveys that use an electrical current to find holes in the geomembrane. So if there is a hole, the electrical current can pass through that hole into the ground, and that's picked up by a cathode on the other side. Another key to good performance is having intimate contact between the geomembrane and the underlying soil or geosynthetic clay liner, if that's used. If you don't have intimate contact, flow can occur underneath the geomembrane and increase the amount of leakage from the facility. So we want to minimize the amount of wrinkles and have the geomembrane in intimate contact with the underlying material. The last key that I'll mention is to have a low hydraulic conductivity material below the geomembrane. So if there is a defect or hole in the geomembrane, it can't migrate very far. The leachate or liquid can't go very far because there is a material underneath the geomembrane that has a low hydraulic conductivity, such as a compacted soil or a geosynthetic clay liner.
Okay, wow, that was great. Thank you so much, Tim. That was a really great summary of geomembranes. You covered what a geomembrane is, the primary function, as well as various applications of geomembranes, and also the key factors essential to good containment.
Great. And so that's an introduction to geomembranes, or Geomembranes 101. In a week or two, we will post another podcast titled Geomembranes 102, where we'll dive a little further into some of the details of designing, constructing, testing, and using geomembranes.
Can't wait.
If you have any questions or would like additional information, please email me at fabricatedgeomembrane@gmail.com or visit the FGI website at fabricatedgeomembrane.com.
Thanks, Tim.
So we'll end with our taglines. Mine is, quality installed faster when you factory fabricate first.
May all your geomembranes be factory fabricated. Thanks for listening, everybody. We'll catch you next time.